Example 3, using the StatCrunch to find binomial probabilities. Now, according to CTIA, 55% of all U.S. households are wireless-only households, no landline, and there are n equals 15 independent trials. We define a success as selecting a household that is wireless only. The probability of success P is 0.55. The possible values of the random variable x are x equals 0, 1, 2, all the way to 15. Now, we want to be able to use StatCrunch. So in order to use StatCrunch, you can see here what it looks like. You want to go to Stat, highlight Calculators, and then select Binomial since we're dealing with a binomial probability. And then you're going to enter the number of trials, which is n, the probability of success, which is p, and then in the pull-down menu, you're going to decide if you want to compute either less than, greater than or equal to, or greater than, and so on. And then finally, you're going to enter the value of x, and then you're going to click Compute. So the first question is, what is the probability of obtaining exactly 10 wireless-only households based on a random sample of 15 households? Well, we have n is equal to 15, p is equal to 0.55, and x is equal to 10. So you have to know that when it says x equals 10, you're looking for the probability of exactly 10 that are wireless only. So let me open this StatCrunch up. Okay. So again, as we stated before, you're going to go to Stat, Calculators, and then select Binomial, and then you're going to see the Binomial Calculator. Now, you look down here at the top, you either have Standard or Between. Now, we want the standard for now, okay? And so we know that n is equal to 15. So we're going to change this n from 10 to 15. And then we're going to put in the value of p to be 0.55. So 0.55. And then we're going to say that x is equal to 10. So we're going to change this symbol to be equal. So this is the menu for that. And then we're going to put in the value of 10. And then select Compute. Now you see here, they give us the probability. So let's take a look at that. So we would say that the probability of getting exactly 10 households out of 15 that are wireless only is 0.1404. So let's just go ahead and show that here. Okay, here's our binomial calculator. We got n is equal to 15, p is equal to 0.55, x is equal to 10, and then if we round that to 4 decimal places, we get 0.1404. And we would say that in 100 trials of this experiment, that is, if we surveyed 15 households 100 different times, we would expect about 14 trials to result in 10 households that are wireless only. And then recall that if we take 100, or if we take 0.1404, multiply that by 100, that gives us 14.04, which is approximately 14. Now I want you to compare if you were going to be using the formula. So if we use the formula, you can see that putting in that formula still gives us the same result, but just a longer way than what you see over here. Okay. Now let's take a look at Part B. Part B, it says, what is the probability of obtaining fewer than 3 wireless-only households based on a random sample of 15 households? So it's really important to understand what you're doing here. N is equal to 15, p is equal to 0.55. The phrase fewer than means less than. So the values of the random variable x less than 3 are x equals 0, 1, or 2. So that means that you're looking for the probability of x being less than 3. So what we can do is we're going to come in here, open up our calculator. So again, we still have n is 15. We know that p is 0.55. Now we're going to change this inequality symbol to be less than. We're going to put the number 3 in there, and then we're going to select Compute. And then you're going to see what our probability is. Rounding it to 4 decimal places gives us 0.0011. So let's take a look at that. There is a 0.0011 probability that in a random sample of 15 households, fewer than 3 will be wireless-only households. So again, let's take a look at that. There is our StatCrunch result. And it says here that in 1,000 trials of this experiment, we would expect about one trial to result in fewer than 3 wireless-only households. So remember that if we take 0.0011, multiply that by 1,000, that gives us 1.1, which is approximately 1. Now let's compare that to if we actually use the formula. So if we use the formula, you can see how much more problem that we'd have to do. We'd have to solve each of these, and we end up getting the same result if we were using the formula and doing this by hand. Okay, next, let's take a look at the next one. It says, what is the probability of obtaining at least 3 wireless-only households based on a random sample of 15 households? So the complement of at least 3 is less than 3. Because the probability of x is less than 3, we found that we had to find and use the complement of probability of x is greater than or equal to 3. So that means at least 3 is the same thing as the probability of x is greater than or equal to 3. So again, you got to know how to write that and use your translations from the previous lectures to know what you need to do to put into StatCrunch. So let's go ahead and do that. So now we got StatCrunch. Again, n is equal to 15. We know that p is equal to 0.55. And now we're going to go ahead and change this to be greater than or equal to 3. Select compute, and then now you're going to see what our probability is. So rounding this to 4 decimal places, we're going to get 0.9989. So there is a 0.9989 probability that in a random sample of 15 households, at least 3 will be wireless-only household. In 1,000 trials of this experiment, we would expect about 999 trials to result in at least 3 being wireless-only households. So again, let's take a look at this on StatCrunch. There is our value. And now remember that 1,000 trials of this experiment, we would expect 999 trials, because if we would take 0.9989, multiply that by 1,000, that would give us 998.9, which is approximately 999. Now let's take a look at what that would look like using our by hand. So what we did is we used the at least, and remember that the at least is taking the complement. But here you can see how we get that result by plugging it into StatCrunch. And the last one, it says, what is the probability of obtaining between 5 and 7 inclusive wireless-only households based on a random sample of 20 households? Well, recall that n is equal to 15, p is equal to 0.55, and the word inclusive means including. So we want to determine the probability that 5, 6, or 7 households are wireless only. So that means that we're looking for the probability that x is going to be in between and including 5 and 7. So let's open that up into StatCrunch. So now, since we're looking for the value of between, over here we're going to click this where it says between. And again, we still have n is equal to 15, we still have 0.55, and then we're going to put the first value, which is 5, and then we're going to put the second value, which is 7, and then select compute, and there is our probability to 4 decimal places, 0.3210. So the probability that the number of wireless-only households is between 5 and 7 inclusive is 0.3210. And again, this is what it looks like using StatCrunch. And so in 100 trials of this experiment, we would expect about 32 trials. Because again, if we take 0.3210, multiply that by 100, that gives us 32.10, which is approximately 32. Now again, let's take a look at what this would look like using this by hand. We still get the same result, it's just a longer way of being able to get that. So again, what we've done is use StatCrunch by finding the binomial probability calculator.